This is parsing made kind of sort of easy-ish using Marpa. This is the slides URL for anybody who's interested in it. It's also on ACT. And I'm going to start with a little bit of an apology. I was a last-minute fill-in on the schedule here, and so I have written these slides mostly, but not practiced them. So we'll see how that goes.
Welcome to Yahtzee.
Thank you for coming. Good enough for me.
So this is my information, just if you're not sure if you've seen this guy around. I'm on IRC as Hobbs. I'm a Rodland in a bunch of other places. I work for Shutterstock. We're hiring. You've probably heard that a few times. So just for anybody in here who's not really sure, like, what is the subject of parsing? Basically, if you're taking data from somewhere, it could be binary, it could be textual, and you are getting information out of it into some kind of structured format, then you're doing parsing. And traditionally, parsing is broken up into phases. The first phase is called lexing or scanning or tokenizing, where you look at your information and you break it down into chunks and you identify what kind of thing is this. Is it a number? Is it an operator? Is it a variable? Is it something or other? And then parsing takes those tokens and it strings them together according to some kind of rules, some kind of grammars, and then more often than not, you end up with a parse tree as a result of that, and then you can take that tree of information and you can do something more useful with it. Some of the tools that we use in Perl for parsing, regular expressions. Perl has a great regular expression facility, so you can build your own. There's a pattern m etc. /gc, which lets you check at a given point in my input, like check a whole bunch of regular expressions. Do any of them match? Yes. If I found one that matches, great, I'm going to go ahead and do something. If not, I'm going to try some other ones. And that's such a cool pattern that Paul Evans created a module called parser MGC from the MGC, which is basically a very simple kind of recursive descent parser just built around that pattern and combining them together. There's YAP, which is more or less a Perl port of Yak, which is probably better known today in its GNU form of Bison. Parse rec descent is a Damian Conway module that is very flexible for doing parsing, and regex grammars is basically a newer and scarier version of parse rec descent, also by Damian, that does its work completely within the regex engine in Perl 5.12 and up, I believe. And then there's Marpa. Marpa is relatively new. First version was in 2011, and it continues to be actively developed to this day. And it uses a parsing algorithm called the early algorithm, which is not relatively unknown, but early is pretty cool. It can handle every grammar in the universe. It doesn't have restrictions like, you know, this only handles LL grammars or cannot handle left recursion or all kinds of things that you have in certain types of parsers. It supports advanced things like modifying your grammar at runtime. So if you have something where, like, you want to for instance, you know, you're parsing a programming language and you define a subroutine and then you want to recognize that as a special kind of thing in the future, you can do that. It can report errors pretty accurately. It's fast. It's written in C, and then the Perl library is a wrapper around the C library. And the early algorithm itself parses. I forget what the exact class of languages is, but Jeffrey always says every language that you've used in every practical parser, it will parse in basically linear time with the length of the input, which means that it doesn't have like a major explosion with backtracking, and it does other cool stuff. As a warning for the rest of this material, I'm not a PhD in parsology, and I'm not actually a primary Marpa developer. I don't know everything that there is to know about it. I'm kind of evangelizing here. That's from the Greek for a bringer of good news. I think Marpa is some pretty good news, and I want some more people to get involved with it. So this is just to get in front of you sort of an example of how you can parse something with Marpa, and so it's declaring a grammar. If you look in the section that says source, the first couple lines they're just setting up some defaults. We don't need to go into detail about that. And then we're parsing like a very simple kind of mathematical expression where we have multiply, divide, add, subtract, parentheses for grouping, and numbers are basically just sequences of digits. And so we're saying an expression is a number, or it's a parenthesized expression, or it's a multiplication, or a division, or an addition, or a subtraction. And the different bars for separating alternatives, if you have a single bar between two alternatives, then they are at equal precedence, and if you have two bars between, then it drops down a precedence level. So it does precedence parsing for you kind of in a built-in way. And so expression is a : equals rule, which means it's a grammar rule. Down below, number and white space are defined with a tilde, which means that they're token rules. And so we're saying that a number is one or more digit characters because I didn't want to write something more complicated. White space is one or more space characters. And : discard is a magical rule that says between tokens we will ignore any sequence of whatever matches : discard, which is white space. So we're saying white space is free between tokens. And bless package here, you see every rule has bless attached to it, well, all but one. And so this is and we're using default action values, which means it's just going to take the subrules that it finds within each rule. It's going to collect them into an array reference, and then it's going to bless that array reference, so you get a sort of a parse tree out of the box. And this is some driver code for that grammar that I just defined. And we're going to do a simple thing. We're going to say, while we have lines to read, initialize a recognizer. R is for recognizer, G is for grammar. With that grammar, feed it some input, get a value out of it. If the value comes back as not defined, that means there was a parse error. In the real world, we could display a much more useful error, but I'm trying to make the code fit onto a slide. And if we do get something back, then we're going to use data printer to print it out. And I'm going to press the wrong button. My apologies. All right, I'm going to run some code. So we're just going to use data printer to print out what's returned here. And so you see I typed in two numbers and they got blessed into number objects, and then the addition expression that contains them gets blessed into an addition object. If I do 1 plus 2 times 3, then I get an addition which contains a number and a multiplication. If I do 1 times 2 plus 3, then I still get an addition that contains a multiplication, but everything precedence worked in the appropriate way. There we go. So with a parse tree and with blessed objects, well, we have objects. We can give behavior to objects. So suppose we take all of those classes and we define on each of them a method called evaluate. A number just evaluates by nummifying. A multiplication evaluates by multiplying its two children. An addition evaluates by adding its two children, etc. So those are all of the things that we have. And so now instead of using data printer, what if we just call evaluate on each thing? Why are you being a little bit finicky? There we go. What a surprise. That's almost complete code. If you look at this, basically almost, every line of this was on a slide. So it's a relatively compact program that's about what it takes to get up to speed with Marpa with a simple grammar. So that's with a grammar. We gave our default rule an action of values, which just says for everything, produce an array ref. You can also use custom actions to derive things as you parse, which means the thing you produce is not even necessarily a parse tree. An action can modify a data structure so that you can build something up in an external data structure as you go, or keep track of things that you're parsing. And actions can modify the grammar, as I mentioned before. And one cool thing is that actions are run when you call that value method on the recognizer. They're not actually run during parsing. Something that I've seen, especially in some of the recursive descent parsers out there, is that if you define actions, they'll get called, and then it'll say, "Oh no, it'll backtrack. It'll say that's not something I want to do," and your actions get run over and over again. And if they're expensive, then that makes parsing really kind of painfully slow. So Marpa does something more clever. It just keeps track of where it found all of the information, and then it's when you call values, it knows what parse it actually wants, and then it runs your actions based on that. And so here's an example where I'm going to use actions just as a quick way of extending the parser a little bit. I'm going to redefine number. Instead of being a token, it's going to be a rule that can either be a hex number or a decimal number. I used 2 bars there. I could have used 1. That's a little typo. And a decimal number is still a sequence of digits. A hex number is 0x followed by hex digits. Hex digits is 1 or more of hex digits. And if we do that, so now, am I looking at the right one? Yeah. Okay, so now I have 1 plus 16, even though I wrote OX10. There we go. And so the thing that I think is coolest about Marpa is that using the early algorithm, as I said, it never backtracks. It does sort of a time-space trade-off. And so what it does is if there's multiple possibilities in a parse, it will keep track of all of them in parallel. If a parse is possible at this point, it's kept alive. If it runs into an error that there's no state that it can possibly move into, then it's thrown away. If we've thrown away all of our possible parses, then obviously we have a parse error at this point. And the algorithm also allows you to ask the parser, among all of the possible parses at this point in the input, what tokens could occur next. And one of the things that you can do with that is something that Jeffrey calls the Ruby slippers. If anybody has ever looked at the HTML5 spec, it basically explicitly asks for this kind of thing. HTML5 or HTML in general has all of these rules. It's a language where a lot of things can be left implicit. If you try to put a tag inside of another tag that it's not allowed to be inside, then the spec says, well, pretend that you saw a closing tag for the tag that this is not allowed to be inside, or the entire stack of tags up to that point. And using Marpa's ability to define what is expected next, you could actually define that. Like, you could define rules for block tags, inline tags, whatever kind of things HTML requires of you. And if you see, this is expected and this is not what's coming up next, but I know how to get into that state, then you can inject some tokens into the parser to make that happen. There is actually an example on Jeffrey's blog, Ocean of Awareness, of doing exactly that. So that's sort of the end of my intro kind of crash course section, and the second part is a little bit more story time about some recent Marpa development and about me. I like parsing things. I like making computers do useful things. And I have always had a fear of lexers when I've looked into any of the really heavy-duty parsers, and they want you to tokenize stuff up front and make an upfront decision about what is this thing that we're looking at, because it's hard. Without the context that the parser provides, how is the tokenizer supposed to figure out what a thing is? And the answer is sometimes you do some really scary things, as Perl does. I can't think of it off the top of my head, but for example, like use module version, I think does some interesting things to actually pretend that it saw some completely different code than what you wrote. It like goes backwards and erases what it did and did some completely different things. But there are options out there, parse rec descent, regex grammars, parser MGC among them, that. Okay, yes.
Perl 6.
That don't make you do that. And the ones that I've listed there are all recursive descent parsers. I believe PegX is not, but recursive descent implies backtracking. Backtracking implies if you don't write things carefully, then things can get really slow. Because you just have possibilities of combinations within combinations. It's something that you see in the Perl regular expression engine as well. If you uncarefully write a regular expression, it can backtrack forever. But with so I think my speaker notes disappeared, which is unfortunate, but I was reading about Marpa in an early stage, and I had an idea, which is it has, okay, are these, okay. What I wanted to do was delete this slide or something. I really apologize for this. But Marpa has this kind of speculative parsing ability, or the ability to keep multiple balls in the air at the same time, and you can feed it multiple tokens at a single point. So if you match all of them and you give them all of them to the parser as alternatives, then it can resolve it at a higher level. So at the time when I came into Marpa, which was when Marpa XS was the thing, Marpa R2 had just come out. This was the way that you drove it. It didn't come with a lexer of its own. You were just expected to provide one. So I've kind of abstracted it as this $lexer next token thing. Get some token from the input, pass it to the parser. If the parser accepts it, then good. If it rejects it, then do something about the error. At the end of input, then request a value from the parser. If it gives you something, then great. If it didn't, then you must have had a parse error at the end of parse. And this is a fairly standard way to drive a parser. but I was looking at these features that were available, and I said, what if you move over the input one character at a time, and you do this crazy thing, which is to say, advance one character, ask the parser if any tokens could possibly start at this position. If so, then ask a lexer, do any of them start here? If so, then pass them whatever set of them there are to the parser as alternatives. If nothing's expected to start here, then we just move on to the next character. When we reach the end of input, we do the same thing, ask the parser for a value, see if we had a successful parse. And so I said I was trying to eliminate the lexer, and I did I? But it doesn't have to make up its mind. All it has to do is answer the question, does a thing start at a place? Because all of the context juggling is done at a higher level by the grammar. And you can entirely do away with things like the longest token rule. This is basically the maximum ambiguity brute force lexer. And this code sample is honestly printed too small to go over, but if you care to look at it in the slides, I did post the slide URL at the beginning. But basically, this implements what I just said using regular expressions. If you give it a table like this, then it will output tokens for the kind of thing that you want. And I had another crazy idea because I've been on and off working on a project that no longer has any steam behind it, but there is a project to turn TAP, Test Anything protocol, into an internet RFC. There's a draft. It's not been accepted. It's not really been edited in a few years, but I started this project a while ago. And I maintain basically a parser that is not meant for real production use, but is derived from the RFC draft as a reference implementation. And every now and then, I try to rewrite it using different parser technology to teach myself that kind of parser. And so I wanted to implement that using Marpa, and I was trying to figure out the best way to do it, and I had a crazy idea, which is TAP is a line-based format, and it has this interesting feature called junk lines, which is that if I see a line and it makes sense as TAP, then I'm going to interpret it as TAP. But if I see a line and it doesn't make sense as TAP, then I'm going to assume that the test harness just prints other random crap onto standard out, and I'm going to ignore it. And that's kind of hard to do with a conventional parser that parses as a document. So I created a parser that would just parse one line of TAP and output an object for that. That would say this is a plan, this is a test result, this is a comment, this is whatever. And then I realized, well, hey, isn't the format that Marpa takes tokens in as input is an array reference? It doesn't even mind whether it's an object or not, so you can pass in what you like, which means that I pass the output of my line parser into the document parser, which says expect a plan, expect test results, expect whatever, and that works. And like I said, it makes that junk line behavior easy, and it also gives you error reporting, because instead of reporting errors that are based on the tokens within a line, it can report errors that says, I expected a plan, or I expected either a result or a comment here, but you gave me a plan but I don't expect a plan because I already have one. And so you can actually be more user helpful with that. And so I wrote a blog post about that and mentioned it on the Marpa mailing list, and it sparked a discussion. And what it led to was the current interface to the current recommended interface to Marpa, which is Marpa R2 scanless, which actually uses 2 grammars under the hood. The stuff that you saw before with the : equals grammar rules runs in one parser, and the stuff with the tilde token rules runs in another parser, and the output of the one feeds the other. That actually, this is what brought it together and allowed you to define them both within a single grammar definition. And yeah, I got ahead of my slides a little bit again. And so that's that. And recently was added a feature called LATM, longest acceptable tokens match. So Marpa's lexer is not the brute force one that I showed off before. To be honest, mine is a little bit crazy.
Very user-friendly, actually.
Well, no, but I mean the algorithm behind it.
It's a cool algorithm.
Yeah, it could actually be wrapped up. I even suggested, well, what if you take LATM and you make it AATM, all acceptable tokens match, and give it the same interface, but use my algorithm.
For parsing English, that might be a good thing.
Yeah. And the answer was, yeah, we could do that, but it would make it really, really easy to write grammars that would make the number of parser states explode. You're not going to have infinite backtracking, but you might use infinite memory, and that's not so good either.
How do you define acceptable?
So acceptable is a token that the grammar expects at this point in the input. So it's going back to that early introspection. And so it says among the set of tokens that are acceptable to the grammar at this point, try matching all of them. And of the ones that do match here, take the longest one that matches. If there's a tie for longest, then it will still present them both as alternatives to the grammar. And this works almost as well as what I presented without being completely crazy. Having some kind of a longest match rule does ensure that your parser is much more likely to move forward. And that's the end of the materials that I presented. This slide links to some of the Marpa community, which I would encourage you to join if you're interested. Marpa Parser is a mailing list on Google Groups. Jeffrey Kegler, the lead developer, has a blog, Ocean of Awareness, where he posts interesting things about Marpa. Another fellow whose name I forgot to write down is working on something called the Marpa Papers, which contains some user documentation and introduction, and tutorial is the word that I'm looking for, that is not in the pod, as well as some technical explanations. And there is an IRC channel on Freenode #Marpa. And I have run a fair bit under time, so if there's any questions or discussions that we'd like to have, I'm definitely open to that. Did I talk too fast? Yes?
Can you give an example of that time you parsed something? Like, what were you solving? What were you doing?
Let's see. Config files, that's kind of a crazy example, because by now every config file format you want, somebody has probably already written the parser for. But I've done it on my own in the past for different kinds of config files. If you want to read something that looks like an Apache config file or a bind config file, or all of these formats that people have imagined. I've written one to read weather reports. There's a standard computer format for weather reports that come from airports called MEDAR, and I've written a parser for that. plenty of things, but I'm not very good at coming up with examples off the top of my head. But any time you have, and I mean like a JSON parser, again, somebody's already done that for you in every language you probably ever want to use, but somebody had to write that, and somebody had to do it using some kind of parser technology. YAML.pm, the pure Perl version, is an agglomeration of those M, etc., GC regular expressions written by Ingi. Don't look too closely if you value your sanity, but it does work. Anything else? All right. Well, thank you very much for having me.